Okay, we're coming up to our last project of the semester, and we're going to do a digital design for the lower class 2 modification 1. I'll bring the model in here so you can see it. But before doing so, we have to have an idea of what type of design that we're going to create based on the principles of design. I'm going to block this out and survey analog, and then we'll also do digital. But before designing, I need to have some understanding of the principles of design. I notice this is a class 2, which is a free end, and a modification 1 on the other side. And we know from our studies this semester that on the free end, we're going to put the mesial occlusal rest to move that fulcrum line more anterior. And one of the 3 stress-breaking clasps on this terminal abutment, 3, 5, would be an I-bar, Roach clasp, or G-clasp. I think for simplicity's sakes, we'll move into the G-clasp. What I've done in advance, I need to have an idea of the height of contour. And as you can see here, I've already surveyed the height of contour and measured 0.010 or 0.25 millimeter undercut gauge. Whether this is going to be an I-bar, Roach clasp, or G-clasp. And then I can freehand the rest of the clasp itself. On the reciprocal side, I'm going to use blue for passivity and on or above the height of contour, closest to as possible because it looks like it's close to the incisal edge here or the occlusal surface. So the free end side is now accomplished, and now on the dentate side or on the modification, I could go with any type of clasping I choose fit. If you wanted to make it symmetrical, you could use the G-clasp, and things would all depend on the longevity and prognosis of the 4-7. But as you can see, the dentist here prepared the distal occlusal. Looks like for an Akers, the reciprocal is on or above the height of contour. I'll outline the occlusal rest. And I've taken the liberty of measuring 0.010 or 0.25 undercut gauge. Roughly a third of this clasp will remain below the height of contour, the terminal third of the clasp. Now we get to the molar here, according to our rules of design, clasp the teeth adjacent to the edentulous area. That's why you didn't see me surveying 4, 3, 2, 1 up here. It's not necessary. But you can see that the teeth, the abutments are the teeth adjacent to the edentulous area, 3, 5, 4, 5, and 4, 7. If these teeth are compromised, or have a poor prognosis, then maybe something needs to be done restoratively or surgically beforehand, before proceeding with the cast partial. If we choose to proceed with the cast partial before any restorative or surgical work is done, then we run the risk that our prosthetic may last a month or very short term before something happens to the dentition, which would be really, I think, not in the patient's best interest. So I'm going to outline the mesial occlusal rest. I see here at the distal buccal line angle, there is no undercut. But I see there's plenty on the lingual. So I'm going to choose to go around this abutment tooth with the ring clasp. And that'll originate from the mesial guide plane of the 4-7 and wrap all the way around, engaging the mesial lingual undercut of 4-7. Naturally, I got guide planes on the mesial of 4-7, guide plane on the distal of 4-5, and a guide plane on the distal of 3-5. So I have my abutment teeth. But I mean, I didn't really have to write it down. I would usually have that in my mind mentally and start off with the rest of the design. And really, I was a little bit out of order. I would start with the outlining the edentulous areas first, and outlining these retentive carriages first, replacing 3-6 and 3-7, and then external finishing line down here, and replacing tooth number 4-6 with an acrylic denture base. And then I'm going to do my abutment teeth, which I've already done. And last but not least, major connector and any considerations for indirect retention, because we have a free end. My fulcrum line is a line drawn through the two most terminal abutments. Measly bisect midline, something around the 4-3 would be a really active indirect retainer. But for symmetrical sake, I'll probably apron both canines. I'll come up here, and this is preventing the tipping and any kind of torsion forces on my free end design. And this is going to really counteract and minimize the rotations, the anterior posterior rotations of this design. So I'm going to go in here and finish the outline of my lingual bar, and you can see it's symmetrical, and there is no straight lines in the design. I'm very close to my 3 to 5 millimeters of tooth number 4-1, but I think I could sneak it down here, almost converting into a sublingual bar at this moment in time, but I think I can squeeze one in there. I think that might be a draw. So now I need to go ahead and survey and block out. Now I've already surveyed the abutment teeth, maximizing my path of insertion, but I also need to translate this to a prescription. Whether the prescription is going out commercially to a third-party dental lab, or this is my expectation from the dental office. So the illustration would entail exactly what the design is. Unfortunately, in the dental community, we don't receive these types of complete prescriptions. But here at school, we can really be valuable to our clinicians if we can illustrate for them, whether it's on the model, whether it's digitally or analog on paper, two-dimensionally, the design. Sorry, I missed my retentive arm here on my ring clasp. Retentive arm in red here. I can put a little X illustrating the engagement of the terminal end of my retentive arms. External finishing line, mesh retention with a tissue stop. Not going too far back on the free end here. Roughly the end of prosthetic sticks, is not to get up on the inclined plane, where we can leave more room for our prosthetics. Over here, from guide plane to guide plane. And then I'm going to put a couple of indirect retainers. And again, this is going to be analog, and then you could hopefully have the opportunity to do both and compare your results, whether it's digital or analog. The same result should be, and then you be the judge what is helping you more. I mean, I think advantageously the digital is incredibly super fast in identifying blockouts and undercuts and path of insertion. But still, casting, trimmings and polishing is the same. Trimming and polishing would be the same if we print this framework in the PMMA. So this is my illustration that my expectation is from you. And then on the right-hand side of the instructions, you would go ahead and write down, major connector, lingual bar, and it can be in short form. G-clasp with mesial occlusal rest on 3-5, and then you can say acres with distal occlusal rest on 4-5, and ring clasp with mesial buccal retention, mesial lingual retention, and mesial occlusal rest. Now, obviously, when we have a ring clasp, it would be more advantageous to have an auxiliary rest on the distal occlusal, but I don't see any preparation there, and I think the occlusion is very tight. And what I've done is just to kind of expedite this. There's one I've done in analog. Slightly different design. I've laid off on the indirect retention and double clasped the 3.4 and 3.5 with the 2G clasps, because in this scenario that I had created at this time, the prognosis of 3.5 was poor, so we're planning in advance. But regardless, we'll leave that aside. We want to go ahead with this drawing, these instructions, this block up. Then I'm going to continue in part B with the a block out of the lower class 2 modification 1.